Oh god. Okay. This is an excruciating, painful, absolute value integral to slow competitors down. But this would definitely, if this was a qualifying exam, I would leave this last for obvious reasons. But let's say we got to here and we have to solve this integral. This is what I would have to do. So notice that for each absolute value, we need to split the bound at 1 because x minus 1 equal to 0. We need to consider that. And then x minus 2 equal to 0, we need to split at 2. And then and so on, we need to split at 3. And then back to 4. Okay? So, oh god. This is going to be tedious. Okay. Unfortunately, we're going to have to do this. So, from 0 to 1, okay, let's plug in like 0.5. I like to think it in decimals because I'm only, I just want to know which is negative, which is positive. Okay, so 0.5, this is going to be negative. That's going to be negative, and this is also going to be negative. So, 3 minus x. Okay, and this is what we left off with. Okay, from 1 to 2, we have 1.5 x minus 1, but then these two are also negative. So I'm just going to go write it as 5 minus 2x, just like this, because this is what this is. This is 5 minus 2x. Okay, this is the numerators is different. Okay, here from 2 to 3. Oh, okay, so we notice that afterwards, this is going to be positive now. So we just leave it as x minus 1. And now 2/3, we see that 2.5, this is positive, but this is negative. So we have x minus 2 plus 3 minus x. So this can cancel out, and we're left with 1. Oh, okay, beautiful. I don't have to deal with that now. Okay, but here, 3, 4, from 3, if we plug in 3.5, everything's positive. So we have x minus 1, we have 2x minus 5. Okay. Oh god. And would you look at that? Okay. So first off, these two are technically the same if you think about it, because negative times a negative is positive. So we have literally x minus 1, 2x minus 5 dx, which is also the same thing as well for 3/4. Okay, here we have a negative version. Okay, we just have a negative version. And then here, luckily we have x minus 1 here. Okay, this is the only different integral that we have to consider. So here, I would draw like a comma and just kind of, okay, so how do we integrate this in general? How do we integrate this indefinitely, right? Oh, okay, well, let's see. I want this 2x. Well, actually, what I would do, well, actually, no, it would be easier to do it together. It would be easier to do it together. 2x minus 2, right? And then now it's just, oh, this is a half of 2x minus 5 plus 5. So I have 1, and I did plus 5, so it would be 3, 2x minus 5. And that would be my, this would be my, the indefinite integral for 3 of these. So I have x over 2 plus 3 halves of ln of, oh shoot, be very careful. We have a 2x minus 5. So it would be a 4 because of a u substitution, right? Let u equal 2x minus 5, and you got that 2, that extra 2. So be very careful, okay? That gets a lot of beginners and intermediates. And then we're done. That's our indefinite integral. And this gets applied for 0, 1, plus 3, 4, and then minus 1, 2. And then here, we have our own different indefinite integral for 2 and 3. Okay? Let's go ahead and clean this mess because holy hell. So now let's go ahead and compute this. And see, we notice that we have a 1 here and we have a 1 here. So that means that we're going to get like 2 times whatever-ish of it. So, because we have a minus here, because that minus is going to make it 2 times the evaluation of 1. So, 2 and then 1/2 of 3/4 of ln of 2 minus 5 is -3, but because of the absolute value, we just have ln of 3. Okay? And then minus 0, plugging in 0, you get minus 3/4 of ln of 5. Okay? Let me plug in 2 first because of the 1 so that we don't forget about it. Okay? So remember it was minus 2. So we are doing a minus version of 1 plus 3/4 of, let's see, 4. Oh wow, that cancels. So that's a 0. So we just have 1. Just 1. Okay. And now let's do the middle part. Plug in 4. Okay. We get 2 plus 3/4 of ln of what? 4 times. So 8 minus 5 is ln of 3. Minus 3, plug in 3, we get 3/2 minus 3/4 of ln of, oh wow, that's also 1. So that's also 0 as well. Okay, 3/2. And then this portion here is like 3 square minus 2 over 3 minus 2 square, 4 over 2 plus 2. Okay. And wow, that cancels out. Okay. So this is like 9 over 2 minus 3. 9 over 2 minus 3. Okay. Now for the tedious part. So we have 2. So we have 1 plus 3/2 of ln of 3. Okay. We have minus 3/4 of ln of 5. That came from the 2, right? Yeah. 10 minus 5. Okay. So now, and then we have minus 1, which this would cancel out with this. We have 2 plus 3/4 of ln of 3 minus 3/2 plus 9 over 2 minus 3. Okay. The ln of 3, we can combine these two. It's ln of 3's. Right? Times 2, 6/4. We get 9/4. 9/4 ln of 3. Minus 3/4 of ln of 5. And then 2 minus 3 is -1. So we have -1. And then we have like 6 over 2, which is like plus 3. So we have like plus 2. Is that our answer? 2, 9/4, 3/4, 5. Hey, let's go! My accuracy is beyond what I thought I could do. Yeah, that's the horrible thing about that integral is that the accuracy. If you try to like bash it like very quickly, you're gonna miss some constants. But there you go, and that's why I hate these absolute value integrals. They're so tedious, very bashy. All right, cool. I'm glad we got to solve that integral, because holy hell. All right, I hope that helps. Thank you for watching, and I'll see you guys in the next video.